Hey everybody, this is Dan, and this is a short video on section 4.3, number 8 on probability for statistics. And this question is a great one to use because we can talk about both or situations and also conditional probability. So I'm going to extend the question here. We've got deaths that were caused where the driver or the pedestrian were or were not intoxicated. So the first question they're asking here is, what's the probability of A or B, or the probability that the pedestrian or the driver was intoxicated? And we have an or situation, you just add them up. So if you take the probability right here of A union B, it's the probability of A plus the probability of B, but you have to also subtract off the both, what's in both categories. So if you look here, here's the driver intoxicated, 165. Here's the pedestrian intoxicated, 320. But we've counted this 96 twice. So if we go ahead and calculate that, that'll be for A, that's the driver, or the pedestrian was intoxicated, so that's 320 over 961 plus 165. This is the driver's intoxicated out of 961. But we have to take away the ones we've counted twice, which is this 96 over 961. Okay, so if we go ahead and just do that real quick, 320 minus, or plus, I'm sorry, 165 minus 96, and we get 389 out of 961. And if we divide that by 961, there we go, 0.405, that's the nearest thousandth, I think. 405. Okay, so that's all they're asking on this one, but I thought, well, this is a good one to teach some conditional probability. So let's say the probability of A given B, and that's what the little vertical line means, given. Given. Move this down a little bit. Okay, so we're going to say, what's the probability that someone died from that the driver was intoxicated, given that the pedestrian was intoxicated. So that formula is just the probability of A intersect B. So the probability that it's in both, and you divide it by the probability of the given. So we're only going to look, in this case, the second item here was the driver was intoxicated. We're only going to look at that as our population. So the intersection, again, is 96 out of 961. Divided by the probability of B. In this case, B is the second item. The driver was intoxicated. So that's 165 over 961. And we can see the 961s would reduce to 1. So really it's just 96 out of 165. And so, let's see here, 96 divided by 165 is 0.582. 582. And then if we want to go the other way, if we flipped around these things? So what if we said probability of B given A? Again, same formula, A intersect B, probability of both. But now whatever comes second is our population we compare it to. So probability of A. So it's really the same thing, 96 out of 961. But now the given, we're saying, what's the probability that the this would be flipped around. Probably the driver was intoxicated, given that the pedestrian was intoxicated. And so now we're going to look at only these 320. So now it's 320 out of 961. So it flips it 96 out of 320, which is 0.3. There we go. So there's a little bit on probability with an or. Disappearing. Okay, and so you just add them up and minus the intersection, and then A given B or B given A. Remember, the second thing is your denominator, or what you're comparing it to. You know you're looking in that group only. So hope that helps.